So, okay.
Yes. Participants, we are starting now.
Great. So, as you can see from the session in the morning, we had developed the proposed scenario, and we had run a pair of so we did the simulation in the proposed case scenario, and we found some results in here. Now, uh, what we'll do now is save this, and we need to create a standard design. So this, so the idea is first you do your proposed, wherein you add all the proposed envelope yeah, things. For example, yeah, based on whatever building envelope, glass, or HVAC system details that you have planned so far. You can prepare uh, the proposed scenario at the first, and then you develop the standard scenario. Alternatively, what you can do is you can also go the other way around. Is first develop the standard building as per ECVC norms, and then improve things in that to see how the energy savings are being impacted. So what I will do is I'll just close this, save, and if you remember where we saved, so all projects that you develop in the eQuest and save it, the default location is in the documents eQuest 365 year project. 365 is the version of the eQuest that I'm using, hence it is saying. So here, as you can see, that we have already done the ECBC practice project. So what I'll do is I'll create a copy of this, and I'll rename this as just for our standard design. Okay, good. And then we again open eQuest. But here we choose so here what we'll do, we'll select the option that says select an existing project to open, and I do OK. It will take me to the directory where I have copied it, standard year design. What I'll do is I can open this from here. So, and then in this, I will make my changes to create the standard building. Now, in this session, what we'll do, we'll often refer to the ECBC code section 9 to see what the modeling requirements are for the standard. So we have developed the proposed, right? Now we'll see what the standard are. Now, the first point is the design model. This says that the standard design shall be developed by modifying the proposed design as described in this table. So we are going accordingly. So we first develop the proposed, and then we are modifying the proposed design, well, as said in this table. So the first thing in this is space use classification. So this they are saying, so this refers to the internal layout and the floor plan and everything. So for the proposed the building type or space type classification has been chosen in accordance to section 2.5. So 2.5, if we go here, wait, this one. So if we go here, we see that this is as per. So we have done this as a business building. as it is an office one. Okay. So what this point 2 says, that my space use classification should be same as proposed. Now, as in the proposed, we already had said that okay, yes, 60% of my area is office space, 10% of my area is corridor, and 5% is my restroom and all. So as we have already clarified that in the proposed, and we are using a copy of the same model, we don't change anything in this. So we don't change the geometry, we don't change the internal layout, or we do not change those figures where we had to go and say that okay, yes, 60% is office and all those things. So I'll go to this. So coming back to the first one, okay. So everything here remains the same, right? This again, space use classification, we don't change it. Just mind that the orientation is also the same for this. There's a catch in this, that whenever you are calculating the standard EPI, the standard design EPI, there is you can see there is a part of orientation in here. Let me see if I can get it. So not here. Yeah, in here, if you see this part, it says that the standard design shall have identical condition floor area, identical exterior dimensions and orientation as proposed, except as noted in ABCD. Uh, in here, the standard design performance shall be generated by simulating the building with its actual orientation, and again after rotating the entire building for 90, 180, 270 degrees, and then averaging the result. So what this means is, once you have done this simulation over here, you need to create four baseline, four standard design simulations. First, having the same orientation as the proposed one. Second is having the same building design and everything as the standard, and then rotating it by 90 degree, and again another simulation rotating it by 180, and then another simulation rotating it by 270. Everything else remains the same. It's just that the orientation changes from 0 to 90 to 180 to 270, and then whatever energy consumption figure you get from all those four results, your standard design will be the average value of the simulation result that you got by rotating them in all four directions. So basically, once you do the first standard design simulation, you copy it and you make it another one, but just change the orientation from 0 to 90 degree, and then again, and then run it, and then again copy it and then make it 180. So yeah, like that you can get all four orientation energy consumption results, and then the average of all those four values will be your standard design orientation. Okay, so we are keeping the orientation, so we are simulating the so we are changing the first standard design case wherein the orientation is same as the proposed design. Everything remains same, the height, the floor plan layout. Then comes the building envelope. Now in the building envelope, if you see what this says, there is a section of building envelope. Yeah, here it says that opaque assemblies. such as roof, floor, door, wall shall be modeled with a maximum U factor allowed in section 4.3.1 and 4.3.2. So if we go to 4.3.1, if you remember, we had chosen, or so if we are simulating this for any location in Kerala, it will be coming as warm and humid. But if you remember, this one I had done with the weather file of Amritsar. So Amritsar generally falls in hot and dry. If I'm not wrong, what I can do, this is I can go and quickly check about Amritsar. Yep. Yep. So if you see here, it says what is what. So Amritsar here, Amritsar falls uh, in the composite zone. So you can see here from here, which I mean, if you choose Trivandrum or Tuticorin, it will come under warm and humid. But as we have chosen Amritsar, this is falling uh, 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 as composite. So if I go to section 4.3.1 for composite, as my building is a business type, the maximum allowable U factor that I can have is 0.33. So here, instead of this, what I will have is I'll have now, if you remember, this is in uh, uh, so everything that goes in here is an IP. So I will have to change this first. So 0.33 divided by 5.678 will come as 0.05, right? So that means the roof surface U value for my for my standard case should be 0.05 BTU. In that case, what I do, that I go here and I say I create a new construction, wherein I say ECBC standard roof design. Okay, and then I say none. And here, instead of a library entry, I just say specific resistance only. Now, if you remember, this is the U value. What I need to input here is the R value. And then U value is the reciprocal. So what I would do here is 1 divided by 0.05, which makes the R value as 20. Okay. And then I say done. Okay. So if I see that the overall R value has been taken as 20. Okay. And similar, I do a similar thing for the above grade wall. I create I create okay, this one. Oh, sorry, here I have to create. I create here ECBC standard design wall. Here I say from none and I do okay. It again takes me to here, and well, and instead of doing it through the library entry that we did for the proposed case, I'll do a specific resistance. And similarly to how we determined what the roof U value should be, here I'm going and checking the same thing that has to be done for the opaque external wall. So there, as we saw, that the Amritsar is in composite, and now see that the now here we have to see the classification. Right, here we see that my building category falls under business, and the floor area for the building that I have right now is less than 10,000 square meter. In that case, the U value of my wall in the standard case should be 0.63. So yeah, that ways again we do the conversion here. So say 0.63 divided by 5.678. So we get 0.11 as U value uh, uh, in yeah, IP. But now we need to select this. Yeah, but here we need to input the R value. In that case, what we do, 1 divided by 0.11. Now it has 9.09. So I'll go here, I'll just say 9.09. Okay, and I say done. I just check this again. Yep. Okay, and I say here done. Again, now I see for ground exposed, but I don't. But there is no standard that ECBC gives for the ground exposed thing. That is the surface that is in contact with the grounds. So hence we can keep it as it is. Okay. Same as what we have in the proposed case. Likewise, we come here. We now door again. ECBC does not specify anything for doors for the standard, so we will keep the same for any doors. Next is the glass. Now, if we see again, yeah, what ECBC says here is glass also has to be changed. So if we come to this, yeah, here ECBC says that the fenestration area shall equal that in the proposed design or 40% of the above grade wall area, whichever is smaller, and shall be distributed on each face in the same proportion as is the proposed design. No shading or projection should be modeled in the standard design, right? And then your fenestration shall be assumed to be flush with exterior wall or roof. Manually operated fenestration shading device such as blinds and shades shall not be a model. And the fenestration U factor shall be the maximum allowed for the climate, and solar heat gain coefficient shall be the maximum allowed for the climate and the orientation. So here we see two things. First is the amount of WWR. So what it says is, if in my if in my uh, current proposed, if the WWR is above 40, in the proposed it will stay the same. But if it is above 40 in the proposed, then my baseline shall be maximum 40, right? Maximum, yeah, 40. So in this case, if you remember, this was the wall to window ratio in the proposed, that is 53, 53, 53, 53, right? So yeah, two types of, so but in the baseline this will be 40, 40, 40, 40. Now if you do a finish here, uh, use the same name from the wizard. Yeah, I would say I would keep the existing name. Oops. So as we can see, there are some errors in here. So just see that once there is any, I mean, if there is an error, no simulation will run, right? Hence it is important to have no errors in this. Now the reason why this error is here coming, so if I close this, if you see this here, it says wall has no heat capacity, U value used. Now if I click on error navigation, it is taking me here. So here it says that okay, I have used this thing, but then there is no thickness in there, and there's no material in this, right? It is taking all these yeah, figures, but there is no material. There's no material in this. So generally, what I do in this is I go. So I'll show you how I generally input this. Is whenever whenever you go into the detailed data edit, right? In here under building shell, if you come down, you will see these are the roof designs that we have already created, right? So here we can see standard roof design, standard wall. So if I double click this, and here I see that I've chosen the layer input. And the reason why it is showing an error, that it shows layer input, but the calculated U value is this. But if you remember, the U value that we calculated from the ECPC for the roof, it was 0.05. So instead of putting in layers, I'll just put U value input, and it asks, and I'll put the standard design U value that I took from here, from this 4.3.1, that is 0.33 changed into IP, right? And then I'm done. And well, and similarly I'll do the same in here. If you remember, it was 0.63, so it was 0.11, and if I do done, if I create done, this is this box here is the check description that is there, right? So here I would say it is showing. I will not save this. Something wrong in here. Mhm. Wall. Standard is no data due to previous error. Okay. Okay, so for the time being, just the so that this does not arrive, we'll we'll take a standard design from here, uh, so that the errors don't come for the time being, and then I can show how we can change it here. Okay. So okay, I'll bring this back. Okay. Okay, so changing of the U values, we'll go into the detailed design mode, and then we'll change it there. Okay. Uh, well, I will show that to you in the end. So okay, as we had finished rendering, I'll just see if the Yes. So here, if you can see, as we had changed the wall to window ratio to a 40, right? The spacing of the glasses had changed. So in case if you so in your proposed case, if your glazing your percentage is above 40, then in your standard case, your glazing your wall to window ratio should be limited to 40 only. Okay. So yes, so that we comply with creating the standard design model. Okay. The next, as you saw in this, that no overhangs or no shading element shall be modeled. As you see that no that blinds or any shade shall not be modeled in the yes standard design. So here we go and say none, none. So no shading or nothing will be modeled. Again, for a roof for roof skylights, we'll keep it same as it is in the proposed. If there is skylight higher than 5% in the proposed, if you see here, skylight area shall be equal to the proposed design or 5% of the gross roof area, whichever is smaller. So if my skylight in the proposed is higher than 5, then in the standard design it will be 5% of the total roof area only, right? And then roof solar reflectance and thermal emittance. The exterior roof shall be modeled using a solar reflectance of 0.7 and a thermal emittance of 0.75 as per this section. So if I come here, so here as there is nothing, so all those things comes in the roof value section, which I'll show you how to change in the detailed design here. Okay. Now next we come to the area, the activity area allocation. All of this shall be same to what it was in the proposed. We'll keep it same. We'll keep the occupied load by activity areas same except for lighting. The plug loads will remain the same. Now if we come here and see lighting, interior lighting standard design shall be determined using the same categorization procedure, uh, that is either building area or space function, and the maximum allowed limits should be either as per 6.3.2 or 6.3.3. So if I go to 6.3.3, there are two types of LPD determination. One is the building area method type. In a building area method type, there is one single LPD value that is applied throughout the project, right? That is same in offices, that is same in your corridors. So if in your proposed you have applied this, like you have not applied say your different LPDs for different space type. If you have applied different LPDs for your different space type in the proposed, then in your baseline also you will have to do it similarly. That means different LPDs for your different space types, which is called the space function method. Right here it says the space function method. It means that determination of interior lighting power allowances by the space function method, and hence shall be done as per these tables. Now, as I am going for ECPC compliance method, and as you have seen that here I have different LPDs for different spaces. That means I have not gone for building area method. I have gone for the space function method. So I need to change these here. So here for office type, what I will see that in my standard yeah, case, the office LPD is 10 watt per meter square. That means you have to change that into 10 watt per square feet. So that means 10 divided by 10.76. So your LPD should be 0.9 in the standard case. Okay. For office, now here you see we have taken 0.0 sorry, yeah, we have taken 0.7 in the proposed. That means we are saving, so our lighting power density in the proposed is lower than what it is in the standard. My standard case as per ECBC, office spaces should be 10 or open plan. Open plan means just like we have in your modern offices, that here there are big office spaces that are open. So even that also, yeah, it is 10. So that means in here I go and I put 0.96. I think it was 0. Sorry, 0.92. 0.92. Then we come to the corridors. Now in the corridors, what we have, uh, now we have to see that what, so here if you see that the corridors, here I have 7.1 as my maximum allowable LPD. So 7.1, again we have to change this. 7.1 divided by 10.76, this is 0.65. So that means instead of 0.6, this will be 0.65. So again, my yeah, my LPD in my proposed is much better than the yes, standard design. Then the third one is the lobby. Lobby we have 1.10. Right, lobby here is the maximum allowable limit is 9.1. Okay, so we go here, we do 9.1 divided by 10.76, we have 0.84. Okay, but in my proposed we have 1.10. This is fine. I mean, that is the whole point of doing whole building simulations, that you can choose some of the areas to not meet these the prescriptive yeah, values here. Right. Now, there may be offices where the lobby area needs some lighting because there are some art forms or anything in the lobby areas. So in the proposed, you need a higher lighting, which is quite fine. Again, so similarly, we come to the restroom. Restroom here, the required is 7.77. Again, we go there 7.7. Divide 10.76, 0.71. Here we have 0.6. So we have a higher LPD here. Now we come to conference rooms. Conference and meeting is 11.5 as per the baseline. So what we do, 11.5, 76, 1.06. So here you see our conference and meeting room is a bit high in the proposed than the yeah, baseline. Then comes the mechanical and the electrical area is 7.1, 7.1 by 10.76, 0.65. My proposed is better, 0.65 here. Now copy room, if I see here, copy room is, I have to see which area meets my copy room description so that I can take the space type that is closest. So a copy room yeah, would be something that has uh, uh, what do I say, machines and Xeroxes and all those things. So business, I can say I can consider service or repair here, right? Where you will have uh, some machines here. So hence we can take that as the baseline. So if you go, we'll do 6.8 in this case. 8, 0.63, and then and at last comes the kitchen and food area. So kitchen and food area, if we go the for food preparation, it's 12.1. We go here 1.12. Go here. Okay. So that's it. Now my lighting changed, right? Now if I see here, uh, okay. So I've created the lighting uh, for the equipment. There is a point here. Wait. Zone, thermal zone saturations. Okay, yeah. For the miscellaneous loads. Now, miscellaneous loads, this contains your plug loads and everything. So here, receptacle motors process load shall be modeled same as the same as the proposed design. Okay. So yeah, that means anything. So yeah, that ways here we are not just, so all the plug loads and everything we are keeping it same as it is in the proposed, right? Then we go next and we see that okay, these all remain the same. Unoccupied hours, this occupancy also, they also remain the same. Schedules, if you see here, point 3, I think, schedules. Uh, all schedules should be same as proposed. So what does schedule say? Operation schedules, that is hourly variation in occupancy, lighting, equipment, power, HVAC operation, etc. So and then temperature, humidity set point shall be identical in the standard and proposed design. Temperature control and thermostat throttling range shall also be modeled identically in both designs. So that means all these main schedules, they will remain the same. Every schedule that I have here, set points again, they will be the same. These what we can do again, this will remain same. All the schedules and set points where we have implied, they will all remain the same. Now coming back to this main schedule information, this is what, yeah. Okay, now in the now comes the HVAC system. If we see the HVAC system here, yeah, HVAC zone design, where HVAC zones are defined on the design drawing. Each HVAC thermal zone shall be modeled as a separate thermal block. So this is for the proposed. So we have already done that. That we have divided the rooms, and then each of the rooms have their own yeah, HVAC thing. So we have so in the baseline, I mean in the standard, it remains the same. Now comes the choice of the HVAC system. What here it says that the HVAC system type shall be as per table 9.2, and the related performance parameters for the standard design shall be determined from the requirements of section 9.4.2. Right. So if I see table 9.2 here, this is where I choose what HVAC system will be there in my standard case. If I have a chilled water system in the proposed, it is not necessary that my baseline will also contain a chilled water system, unlike the other things. So here, how am I seeing this? So here it is saying that any hotels, motels, hospital patients, and all these type of buildings will have a split AC in their baseline. The fan control will be constant volume, and the cooling type will be a direct expansion with air cooled air condenser. That means we are not having, we may have a chilled water system, but then it will be an air cooled one. Chilled water system is only when building areas are more than 12,500 square meter of conditioned space. Only in this, my baseline will have chilled water with water cooled condensers with VAVs in the standard. Now, what we have is buildings. So what we have is, so our building is less than 12,500 square meter of conditioned building, right? So the first thing is we have to choose a variable refrigerant flow, constant volume, but it is a direct expansion with air cooled air condenser. Now, the first thing that we see is whether our building type falls in either of this. Whether is it a hotel, motel, hospital patient, rooms, hotel guest, resort, villas, mixed use, buildings, schools. So for us, we say that okay, our building is an office, so hence we are going to input a variable refrigerant a flow with constant volume, and then direct expansion with air cooled condenser, right? So what we do here, we go here. So we do not have a chilled water, we have DX coils. Okay, so we choose DX coils. Now here it is interesting. So here we choose DX coils because it asks us to say that the cooling type uh, uh, is direct expansion. That is why we chose this DX coils. Sorry, I just went through. Is there any your questions so far, or have I not seen any of the questions?
Hello.
Hello. Yes.
Question, sir.
Sorry. Are there any questions? Okay, there seems to be no questions.
No more questions.
Okay, fine. Yeah. So in that case, what we do here is we come and for heating, what we see here is where no heating system has been specified, or where electric heating system has been specified in the proposed design, right? in that case, for this, we have to take heat pumps. Okay. So in that case, we go. So we cannot take no heating. So we have to say we have to do this as a furnaces here, right? And the system type. So as we have chosen this DX coil, the system type will be the variable flow. So I think we'll have the export, yeah, packet single zone with furnaces. Okay, and heating we'll keep furnace here, and then we'll change it later on. Okay, so again, every set points and everything, they remain the same. Again, now here again, in the baseline, everything will be auto size. As you can see that here we have air cooled. Now what will change is the efficiency. Now if you see, if I go back to 140, yeah, 7, that uh, all related performance parameters for the standard design shall be determined based on the requirements of section 9.4.2. So if I go to 9.4.2, right, here I see that, okay, what are my efficiency values in here? Okay, so we don't have K chillers, right? There should be, sorry, oh no, 9.4.2. So okay, so here the first thing is components and parameters not listed in table 9.2, otherwise shall be specific. So wait, yep, all HVAC heating on load. Yes, where efficiency ratings such as ER and COP, including fan energy, the descriptor shall be broken down into components so that the supply fan energy can be modeled separately. And then all minimum outdoor rates shall be as per this. Now, for efficiency ye figures, uh, wait, let me go and see. Uh, should, where is that? Just hold on a minute. Apologies for the delay. Just, okay, yep. Here, all HVAC equipment within the standard design shall be modeled based at the minimum efficiency level, both part load and full load, in accordance with section 5.2.2. So in 5.2.2, if we come, now these are the mandatory requirements which you anyways have to take. Okay, now what we have to do here is we come here, and as we have taken packaged unit, right, packaged air conditioning unit, but we have a VRF, so we have to take the EER for a VRF. So for example, as we have seen that that based on the sizing that we get, we take the EER of say 3.02. So you have to see that what is your sizing that is coming, right? In that case, so here we go in the EER for the efficiency. We come and we see that okay, for the VRF air conditioner, uh, we'll take the value of 3.02. So instead of 8.5, we put 3.02. Okay, and then again for the heating, if you see, if I go to the heating, This will there are boilers, minimum efficiency. We are not using a boiler, so as per this there is no minimum heating requirement as per 5.2.2. Hence we keep the heating efficiency to be same, to be same as what it was. Okay, again, now the supply fan and this, if we see in section 9, so if you see, if I go back to this table, uh, here in 9.4.2, what does this say about the fans? So here, if you see, supply and return fan shall operate continuously whenever the space are occupied and shall be cycled to meet heating and cooling load during unoccupied hours. That means I have to use a constant fan, so you know variable speed, right? Okay, and then how we have to input the fan power, we have to do it based on this formula. That means standard design fan power in watts. uh, uh, so what we have to do is, after we do one simulation, we have to see that what is the standard flow, and then based on that into 0.51, so that will be the fan power that I have to feed in here. Okay, so here what we have is in PHP. Right now, based on the auto size, I have to see what comes, right? But for the time being, we'll keep it like this. Okay, again, the schedule of the fan goes like this. Baseboard, there is nothing as such. Economizer, okay. No, where is heating up? Okay, yeah. Yeah, sorry. As you saw here, oops. Okay. No, sorry. I think that this will have to be hot water and some. Yep. So, so I have to choose. Sorry for that. As you can see here, it will say that where there is no heating, then I have to take uh, 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 like a electric heating system that has to be specified with the proposed design. So in that case, what I have to do is I have to take some heating in the baseline as well, and then do it and then apply it to be uh, as electric, and I need to have the same sizing as we had in the proposed, right? Then again, outside all these control systems, if you remember, in this all HVAC control systems, they will have to be constant. So if you see here HVAC systems in this section 9.2, so all the fan controls and everything, they for our case it will be constant. So in this, for everything, there is no outside reset, everything is constant, right? Same for the fan operations as well. Here it is auto sized. here again, primary heating, individual boiler, so everything in this remains the same. For the hot water loop, it remains, everything goes to a constant, right? In the boiler description for hot water, now this is primarily for heating. We have natural gas right now, but then we have to take everything as electric. So we keep, so we select electric boilers here, and we keep it at well, at auto size. And then again, every hot water demand, we keep it same as what we had in the proposed. Non-residential, domestic, hot water, again, all these things remains the same as we had in the proposed, and then we finish it. So that means what we changed in the from so in the proposed model, what we changed was, number one is the u values, sorry, u values. Number two is the so we changed u value for roof, external wall, glass. We changed the glass SHGC. Then we came and we changed the LPD, just the LPD. Then we came to HVAC systems. Like in systems, we changed the choice of systems. We changed the system efficiency. We changed the controls. In the controls, everything became a constant speed. No variable drives. Okay, and then we changed the heating. Sorry, we changed the heating coils. That means whether it is electric and auto sized and constant pumps. So all these are the main changes that we made in the from the proposed to the yeah, baseline. Now, based on these changes, we will be getting the saving. So if I see, okay, it is still giving me those four errors. Now the way, as since I said that I'll show how to change this in the detailed mode. So I close this. Okay, I go to the mode and I go to the detailed data edit. In the detailed data edit, I come here and I say that, okay, I have I just have to put roof u value, and it was 0.05 based on my calculations there, and I say done. Then I come to, okay, this was also there. There's another roof, so just change that to roof 0.05, and then I have the standard design wall here again. Okay, now we come to the glass. Okay, so if I see the glass, so here in my proposed case, The glass that we have has a shading coefficient of 0.2. The U value is 0.33 and the VLT is 0.64. Now, if I go here and I see what the proposed, what my ECBC says about the glass, here it says, as I am choosing this for a composite, my maximum U factor shall be 3 and my maximum SHGC not for buildings above 15 degree north shall have a SHGC of 0.5. In that case, I come here and I say, now see, this is SHGC, right? I need to change this into SC. Here it is, here we need it uh, uh, in terms of SC. So if you remember, yeah, the conversion factor, it was 0.87 from yesterday. So we do this divided by 0.87, which means 0.57. So my SC shading coefficient is 0.57 and my U value is 3. Now 3 is in IP, is in SI. So I go 0.7 is 0.52. So I do 0.52 and that is it for this. Now I save this. Okay, too bad building error with that. Okay, there are still some error it seems. I go here. Okay, I just what's this running? Okay, let me choose this again. Sit down. Choose this. Sit down. There's no data. Okay, there are no medial errors. I'll just save this once more and then I'll again go to these figures to see, okay, my U value input is correct. In here, my roof design value is again, it is layer input, right? Now, in this, what I will do, I'll go into U value and I'll change this to 0.05. Say done. Standard is done. I'll just check if there are any errors. No errors. Okay. Now, just what we need to do is, what we can do is finally we can just have a check. So, so if we go to this building shell and then choose any zone like this, and then what we can do is we can check that what values are inputted in this like as floor or as wall. So here if I see, like if I expand this and choose the wall, here it is saying that okay, under this I have the ECBC, the ECBC standard design wall is chosen for this. So that means, and then for roof, so everything that I've created for the standard one is chosen. So you can change those things from here also, but as we have chosen the standard one, so just making sure that okay, these are already applied in these places, and then we do a save. Again, see what is coming. Standard design wall. It's weird. Okay, this is there. More errors. Okay, yeah. Now after adding that, I have one simulation. So here, as we can see, that based on my simulation, I got a total figure of 16. So I'll just go to this tool and then view simulation output, do a VEPU. Then I have a figure of 16136.7. So what I'll do is I will create an Excel sheet. So Excel sheet. Uh, So here I will say design and energy consumption. Okay, so this is my first. So I'll say standard design 0 degree, right? What 0 degree means, as I have to run four the same simulation, you're rotating over four different orientation. So this orientation is same to the proposed. So here yeah, the total energy consumption for the year is 1616376. 1616376. Okay, this is in kilowatt hours. Okay, now second, we'll do the same for 90, 180, okay, this is 3. Okay, now what we do, as we have created this, we'll just, what we'll do is, just for our reference, we'll just take a snapshot. Okay, this is the first building design. Okay, so as we have it, we save it and we close it. Again, here, if you see, this is standard design. I can copy this and I can rename this as 90 degree. Okay, well, this is the way I do it, because so as I have the records of all four orientations that ways. You can change the orientation in the same yeah, model, and you can do the same, right? So for example, what you can do is, well, as you have taken that, in this only you can open the same your model, and then in the project site, if you go here, there will be a building data. So here, if you see, the azimuth is here is yes, 0. Now if I see it on a, just to, so here this outward section is towards the north, but then if I change this to say 90 in here, 90, and I press done, see, this was in north. So from north, the yeah, my building got oriented towards the east west thing. Now the building entrance is from the east, like that, and then just rotate it, and then you can just calculate it. You don't have to change anything, just rotate it by 90 degree and then run the simulation. That ways, again, if you come, you see that you will have a different figure in here, right? So again, if you see the simulation file, if you open, you see the EPU. In here, it is 1617833. So you go here, you say 1617833, right? This is your standard case for 90-degree orientation. Now, what I will do again, like the last time, I'll just take a snippet of this for the record. Here, standard 90-degree. Okay, and again I can go back and change the orientation. Now I'm just for the sake of time, I'm just doing this thing in the same model. What you can do is create 4 different, just copy the standard design into 3 other and then change the names and then rotate it in every model, and you can run the simulation. Okay, so just here I'm just again doing this. See, it is 90, so I'll change it to 180 in here. Done. If I see, now see my this edge is along the south side. So that means my proposed orientation, this edge was towards the north. Now it has taken a 180-degree year rotation. Okay. So again, I do okay. I run the simulation, got the results. See, again, the figure has changed. I can reload this, so it will get updated. So here it is 1616638. So 1616638. Okay. Mm, I'll just take another snapshot. This, and I will I'll just take it as standard 180. Okay. Then I again go here. Instead of 180, I do 270. Again, if you see, this edge is oriented against the west. Save and then run the simulation, get the results. Read it. So now it is 1615950. So 16159. Okay. Now your standard uh, energy consumption should be the average of all these 4. So your final standard energy consumption should be this figure, and then based on this figure you should calculate your EPI. Now if you remember, in the morning we had a building area of 2643 square millimeter. Now what I do here is, sorry, go and I do this, divide by 2643. Then this is what I get in terms of kilowatt hour per square meter per year. This is my EPI for the standard, right? Oh, sorry, EPI standard case. Okay. Now I need to see the EPI of the proposed case. Now, if you remember, what I can do is, as I've got this, I'll open the proposed case, which is this one. Okay, and I'll close this. I will view the simulation, and here in my proposed, this is 1536289. My proposed energy consumption is 1536289, right? So I would say proposed case energy consumption, or say just to maintain energy consumption case. Okay, so this is our, this is also kilowatt hour, and then EPI, oh sorry, EPI of proposed case is again this divided by 2643. Oh, sorry, something's not right. 2643. So again, this is the EPI for my proposed case. So what I'll do, I'll just uh, okay, okay. So this is my EPI for the standard case, and this is my EPI for the proposed case. Now to see EPI ratio, I have to find. So the EPI ratio is, if you remember, if I go to the ECBC code, and then I go to the first page, EPI determining whole building performance. Okay, so here EPI through whole building, EPI of the building demonstrate compliance to whole building simulation 3.2.3 shall be calculated by using the defined pathway in 3.1 and detailed in section 9. So the EPI ratio of a building that uses whole building performance method to show compliance should be less than or equal to the EPI ratio of the projects listed in 9.5. So if I go here, right, so here I see for composite climate, my building was a office hours, office 24, say office. So my building is a regular year office. So my EPI ratio is is uh, this divided by this, which is 0.95. So this is your final EPI ratio. So in 0.95, that means I meet ECPC requirement. That means my building is ECPC compliant, but it is not ECBC plus or super ECBC. For ECBC plus, this ratio has to be 0.86, but our ratio for this is 0.95. Hence, we need to make further adjustments in terms of LPD, in terms of U value for glass, roof, and then the systems and all these things. So hence, this is how you show that, okay, by this, by running the calculations for the proposed, by running it for the standard for a 0 degree, 90 degree, 180 degree, and 270 degree, by getting all these figures and taking the average of all these four orientations, and then you find the EPI for the standard case, and then for the energy consumption in the proposed, find the EPI for the proposed case, and well, and then find the ratio out of this that would come, well, and then compare this ratio with table 9.5 for composite climate. If it is for any different climate, then see the ratio as per this, right? So this is how you establish ECBC compliance through whole building simulation method. So that is well, all for this session. Let me know if you have any questions regarding this. Please explain how to take height floor to floor and floor to ceiling. So what I would do is, if you have false ceiling, where in that case I would take the floor to that false ceiling height as the floor to ceiling height, and I would take the floor to floor as the so the level of say the floor level of ground floor to the floor level of first floor as the floor to floor. And if you well, and the effective, so by floor to ceiling, you would say that what is the effective height up to which cooling will happen, so that that exact volume of ये calculation is used for the cooling load calculations. So whenever you are inputting the floor to ceiling height, in that case you have to just uh, consider the height up till which cooling will happen. So if there is if there is a false ceiling, then just take it to that level, because your HVAC load will be sized for cooling up till that height only. There is also another question that says, could you please conclude briefly the cooling load reduction strategy while working on energy model? Okay, yeah, that is a good question. So some of the cooling load, now there are two ways of doing energy efficient building. First is through a passive architecture, and second is active design. Sorry, not architecture, passive design features and active design features. Uh, Sorry, for this. There was a follow-up question on the last question. Does that mean bottom of false ceiling or floor slab? Okay, let me give you an example that ways. Okay, so say this is your floor. So yeah, for example, say this is your ground floor, this is your first floor slab. Okay, so say your false ceiling up is up till this height, right? That means uh, that your floor to ceiling should be this, that is floor to ceiling, and this shall be your floor to floor. Now you can ignore the thickness of this thing, so that means you take so if you have say 100 mm of RCC, say as floor, or say concrete, you don't include that concrete thickness into your floor to floor. You just include to from the say from the floor tiling to the bottom of the slab of the upper floor as the floor to floor. And then if you have a false ceiling, your your floor to ceiling would be your tile on the ground floor to the bottom layer of the false ceiling. Now, if you don't have a false ceiling, your floor to floor and floor to ceiling would be equal. See, this you can whatever heat component that is there, your thermal component or thermal property that is there coming from the 150 RCC, below the ground, that will be taken care in the U value consideration. So for the software, what it determines is there is a partition in here, and the property of the partition is taken care in the U value. So whether it is 150 thick or 200 thick, that thing will be taken care by the U value factor. So you don't have to consider the thickness. You just you consider the yeah, the effective height up till which your cooling will happen. Is this clear? Thank you. Okay, now coming back to the first question. Okay, could you conclude? Yeah. So this is active design. Okay. So under active design, no, sorry, under passive design, how you can do is first is your your building shape, right? So whether you want a compact shape or say U-shaped or an elongated shape, okay. Then comes your orientation and, and distribution of glazing. Then comes your wall to window ratio. Okay. Then comes your building envelope. Okay, that means your U values. Okay, U values, etc. Uh, so based on this, so if you have a well-designed system through these, that means you have a smart shape, you have a smart orientation, you are reducing the heat gain into the building by limiting your window to wall ratio, and then of course there is skylight roof ratio as well, skylight roof ratio as well. So you limit these things, and then you have the building envelope by having a good wall, having AC block walls, having insulated walls, having good quality glass, and all these things. So you can reduce the load here itself. So yeah, through passive way, you can reduce yeah, the load here, right? First thing. And then once you have done this, then you can, after reducing the load, so when you're first designing your building in eQuest, what I would suggest that select the building shape, keep everything as same, just do the basic calculation in terms of the impact of the building shape, of its orientation, right? Just do that to see, okay, how, without putting the cost intensive components such as good yes, COP chillers and all those things, control systems, lighting, smart systems, and everything. How, without doing that, you can find the optimized building. So you can do those quick yeah, calculations or those quick simulations. Please refer to the please refer to the uh, yeah, recordings of the earliest sessions, right? And then you can see how you can quickly you do those, and then after doing that, then you can see, okay, in the active design there's also lighting. So lighting power density. Okay. Okay, then comes your HVAC systems. That means uh, your COP, I mean your efficiency, okay, and then comes your tertiary HVAC systems. I mean, whether is it VAV or say FCUs, or they are DX, something like that. And then comes your control systems. I mean, having those profiles, just implementing a PMS, well, having time switches, or turn, well, or on off settings, or say thermostat controlled settings. Okay. For HVAC thermostat controls setting means based on the temperature inside the room, your HVAC will switch on or you're not. And then again, having solar, or say having say renewable energy. Now this can be again solar or solar hot water, right? Say any other, yeah, the wind energy, etc. So these are the total ways in which you can render yeah, these strategies. You can make your building more energy efficient. Did I answer your question, or are there anything else you want to know? If you want, you can take a snapshot of this thing to know. Or what I can do is I can just, yeah, I think that's, just copy this and I'll paste this in the chat. Okay. If you have any further question, please feel free to write it on the chat, or you can say as well.
Participants, if you have any questions, please feel free to ask. Either you can type it on a chat box, or you can unmute yourself and ask. I think there is no more questions, sir.
Okay. In that case, I think we can wrap up. I hope that I was able to answer your questions correctly, and I hope that you were able to have the basic idea of how to run a simulation in eQuest. Now, of course, there are a lot of things that you can well add and then twist and then change, but I believe that you will be able to share that you'll be able to do that as you go forward with with practicing, with importing new drawings, and then making your things. I hope with over the past 3 days you were able to get an idea of what all parameters ECPC controls, and then how they control it, and then how you can input those parameters into the standard building, and then create a standard design through whole building simulation, and how you can create the proposed year design in the uh, uh, through the whole building simulation, and then show compliance with ECPC. Thank you for your patience. I know this can be a bit overwhelming in the time frame that we had, but I hope that you can always refer back to the recordings of these sessions and see how to change what, where, and then how to change the geometry, how to add in those figures and everything. So thank you again. Thank you so much.
So I invite Mr. Thompson from Energy Management Center for vote of thanks.
Good evening, everyone. On behalf of EMC Kerala, I would like to express my gratitude to all esteemed delegates of this webinar for their presence and contribution to make this webinar a great success. So I extend my gratitude to our master trainer, Mr. Arvind Pal, for enlightening us with his deep knowledge on ECBC. For the last 3 days, these webinar sessions were full of knowledge and interesting things were there. Give a deep insights to the ECBC and also on energy simulation. For the I must thank the ECBC cell team also for this organizing this webinar, and they were working hard for the 2 weeks for this event. And then I hope everyone is aware of this building energy efficiency expert empowerment that is organized by EMC. So those who are interested in energy simulation, after attending this webinar, those who are getting interested on energy simulation, they can join this. They can apply for this empowerment. And actually, through this empowerment, actually EMC is providing a training session for the engineers and engineering students to design energy efficient buildings in compliance with the Energy Construction Building Code. After this training, there will be an examination, and those who are clearing this examination, they will get empaneled as BEEE. what's their role is they have to they will be helping the public to design and construct ECBC buildings. Like those will be responsible, or they will be supporting the clients to design their buildings according to the provisions of Energy Construction Building Code, and we will be utilizing their this BEE support in the implementation of Ikoniva Samhita also. That will be getting implemented in Kerala within soon. This Ikoniva Samhita is a similar code that is for the residential buildings. This ECBC is for the commercial buildings, and now Ikoniva Samhita is there for the residential building. The implementation work of that Ikoniva Samhita is also happening in Kerala through this EEB cell, and we are everyone is know. I think everyone will be knowing that the government of Kerala is also promoting the construction of green buildings, and government has decided to provide financial incentives for these green buildings also. So for that implementation also, we are actually planning to utilize the support of this BEE for the evaluation process and everything. The details of this BEE empanelment will be shared by the EEB cell, Energy Building Cell, by email. So you will be getting the brochures and the details by email. So you can just go through the details, and the interested candidates can apply for this empanelment. Once again, I thank you everyone for this making this webinar a great success. Thank you.